in data structures, in order to search for a particular element, we use several searching techniques like linear search, binary search tree. So linear search is like from let's say we have this array and there's n elements. We go through them one by one, comparing one to the other in order to search for a particular element. That is called as linear search. Binary search is like we divide the array into two. Like for example, if it's in ascending order and we here it's from 1 to 10 and here it's from 11 to 20, and the element that I need to search is 13, so I start from 11, I don't go here, so I search this part for this element. Okay, so the time complexity, because it's going from 0th element to the nth element, the time complexity is O of n. But here, since we are dividing and we are skipping some elements, the time complexity that we use when we divide or skip some elements is O of log n. And another thing, if for example the best case is O of log n, if after dividing I get the element somewhere here only, but even after dividing I'm going through the entire length, means like for example I'm searching for 20, so I have divided from 11 to 20 and I'm going one by one, and the last element is 20, so the worst case becomes O of n log n. Okay, coming back to this, the time taken to search for any particular element using these techniques depends on the total number of elements, right? So the more the elements that we have to search, the longer it takes for us to search that particular element. It depends on the total number of elements. So as the number of elements increases, the time taken to perform a searching operation also increases. This is a drawback. To overcome this drawback, we use hashing. Okay, so what is hashing? Hashing is defined as the process of converting an input data of any size. Any size के technical term ఏంటి? Arbitrary size. So we take an input data of any size and we turn it into a fixed size value. Means it's like any data you take, you turn it into an integer value, and that integer value is like fixed for the purpose of fast data retrieval. Hashing minimizes the number of comparisons while performing search element. So like usually in sorting techniques, you have to compare the before element to the later element to search for a particular element kada. So hashing minimizes those kind of comparisons. The time taken to perform search operation does not depend on the total number of elements in hashing, and the time complexity is O of 1. For hashing, time complexity is O of 1. So advantages, it's like efficient search algorithm because we can search for it without with time complexity O of 1, fast lookup, collision handling, optimal for unordered data. See, like we can search for it quickly kada, even if there's unordered data, we can search for the thing we want. Disadvantages, inefficient when there are many collisions. Hashing does not allow null values. Why doesn't it allow null values? It's like null does not have a key. Like hashing converts input data to fixed numerical value kada, so that null does not have a particular value that the hash can convert to. So we are going to get an error like null pointer exception, or the program might ignore the entry of null, or it can cause unpredictable behavior and crash the program. So that's why hashing does not allow null values. Hash tables have limited capacity and eventually flip up. Applications used in cryptographic algorithms, used in database for indexing, used in file systems to search for any files or data blocks, used for cache mapping for fast access of data.